Hi everybody, this video today is going to talk about lesson 7.4, which is still elimination, but it's just another level of elimination. So it's just not a whole lot more at all. Because in the last video we talked about how, like, if you look at the x's or you look at the y's and they match up, then you just add them down. Or maybe you have to multiply one to make it equal the other. Well, in this case, we actually have to multiply both equations. So like looking at this one, like the 15 and the 10, they don't match up, right? Or the 3 and the 7, they don't match up. So we have to think of basically what is the lowest common multiple. And by lowest common multiple, I mean what number would both of those numbers go into. So for instance, 3 and 7, my lowest common multiple would be 21. But 10 and 15, my lowest common multiple would be 30. So there's an example down here worked out that way. Let's take a look at the practice problem over here. We could choose either the 4 and the negative 3, or the negative 4 and the 5. It doesn't matter which one. I kind of think for this one I'm just going to choose the x's and talk about how to do it that way. So my lowest common multiple of these is what number do both of them go into evenly? And that would be 12, right? 4 goes into 12 and 3 goes into 12. So I'm going to multiply this times 3 and I'm going to multiply this times 4. So my new equations, I'll call this equation number 1. My top equation is 12x minus 12y is equal to 3 times 8 is 24. And my bottom equation is 4 times 3 is negative 12x, 4 times 5 is 20y, and the last number is going to be a negative 8. Now, I chose 3 and 4 because that gave me 12. I'm going to add these together now, and something should drop off. And in fact, it does. So I'm going to add these together, 12 and negative 12x. Those add up to 0. That drops off. These two, negative 12y and 20y, they add up to 8y. And 24 minus 8, if I take 24 minus 8, I get 16. So now I have 8y equals 16. I'm solving for y now. So like I kind of didn't think about what I was solving for in the beginning, but if you're getting rid of the x's, that means you're going to solve for the y's. So we solve for y by dividing by 8, and we get y equals 2. All right, there's my y value. Now, remember I have to have an x value also. How do I do that? Well, I plug it back in. And again, as always, it doesn't matter which one we do. I kind of like the looks of that top equation. Seems easy. So 4 times x minus 4 times 2 is equal to 8. All right, 4x minus 8 equals 8. Now, I said it looked easy, but this is starting to look a little bit confusing, but I think it's going to be okay. We're going to add 8 to both sides, and that's going to give me 4x is equal to 16. And when I divide by 4, I get x equals 4. Okay, so my final answer on if I use the elimination method here or any method, I will get the answer for 2. Remember, 4 is the x, it goes first, 2 is the y, it goes second. But of course I do have to check my answer. So in the top equation, I would get 4 times x, which is 4, minus 4 times 2 is equal to 8. And I'm just asking myself a question, does that equal 8? So that's going to be 16 minus 8 equals 8. Yes, it does work in the top equation. Now I want to check the bottom equation. So the bottom equation, I have to go back and look again. The bottom equation, negative 3 times x, which is 4, plus 5 times y, which is 2, is equal to negative 2. And again, I'm asking myself that question, does that equal negative 2? This is a negative 12 plus 10. Yes, negative 12 plus 10 does equal negative 2. So both of those do work. So that is the correct answer. All right, just to recap, it's very similar to what we were doing yesterday. The only thing new is that we have to multiply both equations instead of multiplying one equation. Okay, let's take a look down here at the bottom. 5 and 3 or 2 and 7 does not matter which one, but I also remember have to have one of them negative and one of them positive. So in this case, I'm going to stick with the x's again. So 5 and 3, their LCM is 15. So 3 times 5, but again, I have to have one of them be negative, so I'm going to make that a negative 5 times 3x. All right, when I multiply those, I'm just going to write it right over here because it's just kind of easy for me. I'm going to say 15x plus 6y is equal to negative 3. I took that 3 and I multiplied it times all three things. Negative 5 is going to be negative 15x times 7 is negative 35y equals negative 55. Getting some kind of big numbers. We'll have to see what happens here. So the 15 and negative 15 add up to 0. The negative 35 and 6 add up to a negative 29. And over here, negative 3 and negative 55 is negative 58. This is actually going to work out. You might not realize that, but if you get out your calculator, take negative 58 divided by negative 29. What do you get there? You should get 2. So y equals 2. Of course, that's our y. We need the x. We can use either the top or the bottom. I'm just going to use the top. So 5x plus 2 times 2 is equal to negative 1. So that's 5x plus 4 is equal to negative 1. I'm going to subtract 4 from both sides. I get 5x equals negative 5. I'm almost done. I have to solve for x, so I have to divide by 5, and I get negative 1. So my answer should be negative 1, 2. Of course, I want to check my answer. Let me scooch down a little bit. Okay, when I check my answer, 5 times negative 1 plus 2 times 2, does that equal negative 1? I hope so. This is a negative 5 plus 4 equals negative 1. Yep, it works in the top one. And the bottom one, 3 times negative 1 is my x, plus 7 times 2 is my y. Does that equal 11? That is a negative 3 plus 14. Yes, that does equal 11. Okay, you know how sometimes I say we don't have to do all of these at the bottom? I don't think we have to, but I do want to look at something about this. And one thing, let me tell you, on the first two problems, I don't know if you noticed there was a little bit of a pattern. Let me zoom down where we can see it. The pattern that I'm talking about, you can use as a little shortcut. Do you see how this is a 4, but then we multiplied by 4 down here, and this is a negative 3, so we multiplied by 3 here. So one little shortcut is, like, if you just have a hard time with this and you just want to always multiply that number times that and that number times that, you can do that. Let's look down here at number 1 like we were just doing. So we can multiply this times 5 and this times 3, and we can do it that way. I'm going to erase some space here for number 2. I don't think we have to do all of number 2, but I want to show you some options on number 2. So the easy option is we could just multiply this times 8 and this times 6, because just switch it like we were doing on all these. Now, when you do that, of those 4 numbers that you're looking at, one of them has to be negative. Not 2 of them, just 1. And so in this box here, I do have one of them is negative. Let's take a look up here. Okay, in this information, this little box of information here, one of them is negative. Okay, so as long as one of them is negative, you can just do that little crisscross thing. Now, you can do that, but it's going to give you some pretty big numbers, which is fine. No, nothing's wrong with big numbers. But, so that would give you 48 and negative 48 if you multiplied it. There's actually a number that's smaller. Remember we were talking about the lowest common multiple? And there's a number lower than 48. And that would be 24. 6 and 8 both go into 24. So we can do the 6 and the 8. And that's, like I said, if you don't want to have to think about it, just do that. But if those big numbers bother you and you actually want to get kind of smaller, think about what goes into 24. So 6 goes into 24, 8 goes into 24. So that would be 4 times 6 and 3 times negative 8. Now still, only one of them is negative. But if I multiply this out, this is going to be a 24x and 16 and a negative 32. Okay, so I just want you to know you can always just do that kind of, I'm going to call it crisscross. That's an awful thing to call it, but we'll call it that. Or you can think about it more. Let's take a look at the back page.